Hi, let's look at this hypothesis test question. A medical investigation claims that the average number of infections per week at a particular hospital is 16.3. A random sample of 10 weeks had a mean of 17.7 and a standard deviation of 1.8 infection. You have to test the investigator's claim at a 5% level of significance. Answer the questions below. So 1. What would be the set of appropriate hypotheses? When you see this kind of question, it means that they're asking you to state the null and the alternate hypothesis. So in order to state the null and the alternate hypothesis, you first write HO. HO represents the null hypothesis. HO. Okay. Then you write HA at the down. It represents the alternate hypothesis. The HA, we also write it as H1. Okay. You can also write it as H1. H1. Or HA. 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 Okay. Then you bring a column. You bring column. Okay. Please pardon me. Okay. I'm not using the right machine. So when you bring that, now to state it, let's look at something. What was the claim? The claim is that the infection per week is 16.3. So take note of this word is. The word here is. Okay. Take note of it. Now, when they say is, it means the thing is equal to. It's a statement of equality. Whenever you have a statement of equality, you should know HO has been given. And whenever you have a statement of inequality, you should know HA has been given. Statements of equalities are equal to, greater than or equal to, and less than or equal to. They are statements of equalities. Then the statements of inequalities are less than, greater than, and not equal to. Those two are the statements of inequality. So this time around, you have a statement of what? Equality. So you should know HO has been given. HO contains a statement of equality. So for you to state it, you say mu is, so meaning equal to, is, okay, 16.3. So 16.3. Then to state the alternate, when you come to where the alternate is, to state the alternate, what is the opposite of equal to? The opposite of equal to will be what? Not equal to. Not equal to. Okay. This is how we write not equal to. So not equal to what? 16. Not equal to 16.3. Not equal to 16.3. Okay. So you've been able to state the null and the alternate hypothesis. So you get mark for being able to solve this. This question can be in a theory and it can be in MCQs as well. They can tell you that use this to answer question 140 to 150 to 146, something like that. Yeah. Now, let's look at the question 2. Question 2 says, which test statistic would you use? Now, to know the test statistic you use, what we mean by test statistic is we have F, we have chi, we have Z, and we have T. Those things are test statistics. Okay. Now, they're asking you that, what test statistic will you use? The question they're asking is that, would you use the F? Would you use the T? Will you use the Z, or which? Now, how do you know if you use T, F, or whatever? For this particular question, I think you use T. Okay. My reason for saying that you use T is because, let's look at something. When n is less than 30, at the same time, the population standard deviation is unknown. Look at this standard deviation. is a sample standard deviation. It's not a population standard deviation. It's a sample standard deviation. So since it is not a population standard deviation and the n is less than 30, that is the main reason why we are going to use the t. Okay. Had it been that this standard deviation was a population standard deviation, now I can be confident enough to tell you that, oh, we are going to use the t. But this standard deviation is a sample standard deviation. Somebody will ask, what shows that it's a sample standard deviation? Let's look at this English. There's a full stop here. And look at this. A random sample of 10 weeks had. Look at this English word, had a mean number of 17.7 and a standard deviation of 1.8. When you see this word had, it means that this mean and this standard deviation are referring to the sample. Are you getting it? Mr. Benson had a car and a bicycle. Meaning this bicycle is Mr. Benson's bicycle and this car too is Mr. Benson's car. So if you say a random sample of 10 weeks had a mean number of 17.7 and a standard deviation of 1.8, meaning that this mean is the sample mean and this standard deviation is the sample standard deviation. Is that clear? So because this standard deviation is a sample standard deviation and the sample size n is less than 30, that is why we are using a t. Is that clear? So the test statistic to use is the t distribution. You tell them that it's t distribution. If it's MCQs, you see it in the possible answers. Then you choose t. Okay, we are using t. Okay. Now let's go to question 3. Question 3 says, find a critical value. To find a critical value, this is how it is done. You can sketch a curve for it, but I won't waste time doing that. I'll just go straight for it. This is t. Okay. Now, you ask yourself, what tail test is this? Is it a right tail test? Is it a left tail test? Or is it a two-tailed test? This particular test is a what? It's a two-tailed test. Whenever you have a not, you check where the alternate is. When you have not equal to sign over there, it is a two-tailed test. When you have greater than, it is a right tail test. When you have less than, it is a left tail test. So this particular one is a two-tail test. So because it's a two-tail test, now what was the significance given? You were given a significance of 5%, isn't it? And that 5% means what? 5 divided by 100, which is 0.05, isn't it? So meaning your alpha, your significance, your alpha is equal to what? 0.05. 0.05. Your alpha is 0.05. And you also find something we call degree of freedom, df. Okay, you find degree of freedom. You find degree of freedom. Now degree of freedom will be equal to n. The formula for degree of freedom is n minus 1. Okay, small n minus 1. Okay, n minus 1. Now what is our n? Our n is the sample size, which is 10. So 10 minus 1 gives you what? 9. So our df is what? Is 9. Okay, our df is 9. So after getting the df, then you go, what is your alpha? Your alpha is 0.05. Then you go to the t table. Now when you go to the t table, was it a two-tailed test or one-tailed test? It was a two-tailed test. So you go to where they've written two-tailed test. Please check it. At times there are some tables, they've been interchanging them. They will come and write one tail at the top here and write two tail here. Check it before. Don't always assume that two will be written at the top. So for this one, there is 2 here. So 2 tail is here. And you need alpha 0.05. So this is 0.05 here. Then you trace it down to the degree of freedom of 9. See, this is a degree of freedom, df. 9 is here. 0.05 to the degree of freedom of 9. What do you get? You get 2.262. 2.262. Okay, that is your t. Now, but because it is a two-tailed test, you don't just write t is equal to 2.262. T will be equal to plus or minus 2.262. Okay, plus or minus 2.262. So t will be equal to plus or minus means negative 2.262 and positive 2.262. Okay, so 2.262. So quickly, let's go. Now, the next one says, what will be the value of the test statistic? To get the value of the test statistic, you are going to use the formula for t. Okay, the formula says what? The formula says sample mean minus population mean divided by S, that's sample standard deviation, over square root of n. That's the formula you use. Now, you substitute. What is your sample mean? Your sample mean is 17.7, so you substitute it here. Minus, what is the population mean? 16.3, right? You come and fix it here. The population mean is usually in the hypothesis that you've stated. Divided by, what's the standard deviation? 1.8, so you come and substitute here. Divided by square root of n, and your n is 10. So when you punch it on your calculator, you should get what? 2.4596. Okay, you get 2.4596. You can approximate it to 2 decimal places. 2.4596. 4596. 4596. Pardon me for my handwriting. 4596. When you approximate it to 2 decimal places, it will give you 2.46. Okay, 2.46. At times you can see the possible answers in 2 decimal places. So it will be 2.46. Okay, then let's look at the next one. The next one says, what will be your decision? Now, what will be our decision? To know your decision, you can sketch a curve. Forgive me for my bad handwriting, okay? But please do the writing in your book or your jotter. Now, if this is a straight line, and the critical value 2.262, you plot it here. This place will be negative 2.262, isn't it? And this place will be positive 2.262. This area will be called the region of rejection, this shaded area. And here too will be region of rejection. Negative 2.262 will be here, and positive 2.262 will be here. Now, if positive 2.262 is here, now assuming that you want to come and plot this t, this t2 on this same curve, it would have fallen somewhere here. You know, the positive 2.262 was here, right? This is bigger than this, so it would have been somewhere here. So it has lie at the region of rejection. So because it lies at the region of rejection, you are going to reject HO. Try and plot it and see. 2.262 will be here, and 2.4596 will be here. So you see that it has lied at the region of rejection. That's why you reject HO. So our decision is to reject HO. Then question C says, what will be your conclusion? Now, to conclude, if HO is a claim, are you listening? If HO is a claim, you know, in this question, HO was a claim. So since HO was a claim and you've rejected HO, there is enough evidence to reject HO. Or you say there is sufficient evidence to reject HO. Okay, so that's it. Thank you for watching.